morning, everyone. A few reminders before we formally start our webinar. First, keep your microphones on mute unless you're invited to speak. This helps maintain audio clarity for all attendees. Second, we kindly ask that you reserve your questions until the designated question and answer session, during which we will address them comprehensively. Third, the session is being recorded and streamed live on Sayat's YouTube page for wider access. And fourth, please stay until the end of the webinar. Certificates will only be given to participants who will complete both attendance and evaluation forms. Good morning, everyone. And we formally welcome you to the second session of the Low Carbon Strategies and Best Practices webinar series. And the particular focus of this session is decarbonizing infrastructure, nature-based design, and industrial innovation. To formally kick off our webinar this morning, we let us all welcome the Dean of the College of Engineering and Agro-Industrial Technology, the Chair of the UPLB Interdisciplinary Low Carbon Research Center, and the Co-Chair of the UPLB Interdisciplinary Life Cycle Assessment Laboratory, or ILCAL, Professor Rex B. Demafilis.
Good morning, everyone. Of course, first of all, I would like to thank our speakers, Engineer Gabriel Antonio Pimentel and Engineer Samuel Manlosa Jr. for agreeing and sharing their expertise in this webinar. And of course, thank you sa ating committee who organized the second webinar. On behalf of SEAT, or the College of Engineering and Agro-Industrial Technology, in collaboration with the UPLB Interdisciplinary Life Cycle Assessment Laboratory, which is headed by the Associate Dean Bernadette Magadia and her team, it is my great pleasure to welcome all of you to the second session of the webinar series on low carbon strategies and best practices. Today's theme is decarbonizing infrastructure, the nature-based design and industrial innovation. This dialogue is especially crucial as we navigate the growing impacts of climate change and the global call for decarbonization. The strategies and best practices that we will learn from our speakers today can serve as valuable insights for developing sustainable technologies and policies that align with our nation's goal for climate resilience and green growth. As engineers, researchers, and innovators, we are challenged to explore nature-based approaches and industrial innovation that not only reduce carbon emission but also enhance the harmony between development and natural environment. May today's session encourage collaboration, spark new ideas, and strengthen our collective resolve to design and build a more sustainable future for all. I wish everyone a fruitful and inspiring session ahead. Good morning and God bless you all.
Thank you, Dean Rex. Let us give him our virtual round of applause. Without further ado, let us now proceed to our first speaker with the topic, Building with Bamboo, Empowering Communities Through Regenerative Innovation. Our first speaker, who is a research and development engineer of Base Bahay Foundation Incorporated. He is a research and development engineer at the Innovation Center of Base Bahay Foundation. He earned his Bachelor of Science in Civil Engineering from the University of the Philippines, Los Baños, so one of our own, and is currently pursuing his Master of Science in Civil Engineering, majoring in Structural Engineering at the University of the Philippines, Diliman. Before joining Base Bahay Foundation, he worked as a research engineer at the National Engineering Center Building Research Service, or NECBRS, where he focused on nonlinear analysis and the development of seismic vulnerability curves to reinforce concrete structures. He also served as a faculty member at the Technological Institute of the Philippines, or TIP, teaching core and advanced structural engineering courses. Yes, let us welcome one of our own from Base Bahay Foundation Incorporated, Engineer Gabriel Antonio I. Pimentel. Let us give him our virtual round of applause.
Okay, so good morning, everyone. Let me just fix my screen so I can share the presentation to you. So, just a side note, it's nice to be back in LB, albeit in just an online manner. So I'll just fix the presentation. I'm sorry, there's just some problem with the sharing options.
No worries, sir. I think you are sharing your whole screen with
Yeah,
the
I'm trying to
notes.
share just a portion.
Okay. Okay, sir.
Because I have a lot of notes for today's session. Is it visible?
It is visible, sir, but I think the control is overlapping on the presentation. If we can drag it down or maybe on the side, if
Sorry.
it's covering a part of the slides.
How about now?
It's there's still the your controls are visible, sir. If we can drag it down, it would be better. We can see the whole slide, but the controls are visible as well.
Sorry.
The meeting control.
How about this one?
It's good now, sir. The
Okay, so I
presentation is
just do
now
it without the
clearly
notes.
seen. Thank you, sir.
Okay, so before we start, just a question, Sir Edward. Do we have any international audience? Is it
If
okay for me to speak in Tagalog
there,
in some?
I think there is one who
So I'll just speak
reacted
in
thumbs up, sir. So maybe we have an
Okay.
international audience.
Okay. So sorry for the delay. Um, so for today's presentation, it is titled Building with Bamboo, Empowering Communities Through Regenerative Innovation. So before we start, I just want to give you an overview of what Base Bahay is. So Base Bahay was founded back in 2014 through the Hilti Foundation. So the Hilti Foundation is an arm of the Hilti Group of companies. So the Hilti is a Liechtenstein-based company, multinational company that is most known for power tools and technology for the construction industry. Okay. So before I introduce Base itself, so let's just talk about the problem that we are trying to address here in Base Bahay. So first, the construction industry is the most contributes the most in the global CO2 emissions. So it accounts for about 38% of the global emissions, with I think it's 6% from residential buildings through direct emissions, and then 11% through indirect means. And at the same time, we are another problem that we're trying to solve in base is there's a major housing backlog in the Philippines. So the problem is we have a lot of backlog houses that we have to build, but at the same time, the construction industry is the biggest contributor to global CO2 emissions. So that's where Base Bahay comes in. So we're trying to research ways on how to produce more affordable housing that is at the same time gives off less CO2 emissions. So about Base Bahay, we're just a technology provider. Yes, we build some houses, but most of our work is just trying to get the technology out there for other professionals, other engineers, architects, builders who want to try to use our technology. So we have three arms. We have Base Innovates, our research and development arm. Our Base Builds, our technology transfer. And then next is lastly is Base Enables. This is our training and value chain arm, which I will all discuss later. So why do we use bamboo here in Base Bahay? I guess this is the most self-explanatory part of this discussion. We use bamboo because first, it's a nature-based material that is widely available where it is needed. So why is there a line here?
So I think there was an accidental annotation.
Is that me?
I am not sure, sir, if that's on your part. Yeah, it's already clear now, sir. You may
Yeah, I
proceed, sir.
removed it. Okay, sorry. Okay, so why we use bamboo? First, it's a nature-based material that is widely available where it is needed. So we typically, Base Bahay, our projects are located in the provinces to provide housing options for the marginalized. So bamboos are naturally available there. So it also has excellent mechanical properties. Actually, it is actually not that correct to say that bamboo is comparable to steel, but what I'm gonna say is bamboo is extremely strong, specifically along its fibers. So it's strong in compression. It's also good in bending, but I'm not gonna say it's comparable to steel. So uh, another thing about bamboo, it is a renewable resource. It grows very fast. So bamboo can be harvested about 3 to 5 years after it's been grown. So it's a renewable material. And actually, the species that we widely use here in Base is Bambusa bloomiana. It is locally known as Kawayan tinik or thorny or spiny bamboo. At an average throughout the year, it grows at about 17 cm per day. So that's fast. 17 cm per day. And actually, at its peak season, sometimes from what I've read, it grows for about 40 cm per day. And actually, that species was regarded as one of the lazy species. So it grows a bit slower than its cousins. But at that rate, it's also incredibly fast itself, 17 cm per day. So another thing about bamboo is it has a lower carbon footprint in the environment. It's about 60% lower. And one of the most important things here is using bamboo helps us develop the bamboo value chain. This means that we can generate livelihood for the local communities in the area that we have treatment facilities, because we help support the farmers, we help to create jobs in those areas, in the facilities itself. Okay, so our main product or technology is called the cement bamboo frame technology. And the cement bamboo frame technology is actually based on the Bahareke technology. It's an existing building, traditional building technique from Colombia, in which you take timber, bamboo, and then you put some clay or mud on the walls with some water or something. So we just tried to standardize it. We then we applied it using we applied it with Filipino technology. Okay. So with what allows us to construct our CBFT houses is through the accreditation of innovative technologies for housing of the National Housing Authority. So just to segue a bit, in the Philippines, we have the National Structural Code. So civil engineering students are very aware of this. So we have this National Structural Code, but there is no provision for bamboo in that code. So to work around it, we had this accreditation to allow us to build houses in the Philippines. So it's called IATEC of the NHA. Okay. So some of the features of our CBFT houses is first, because some people, like when we say bamboo houses, the first thing that comes in mind for them is our bahay kubo, right? And normally we have the perception that the bahay kubos are not that great. Like they usually last just about a few years, etc. So there's a perception in the Philippines that uh, bamboo houses are cheap, weak, etc. So that's not the case for our CBFT houses. So it is a permanent housing with with a minimum lifespan of about 50 years, what we would expect from a typical concrete structure or steel structure. It's also disaster resilient, as I will show later. It was tested against earthquakes and typhoons. And it's also insect resistant. That's one of the common questions about our bamboo houses. So it is insect resistant because we follow a treatment program that we share with our treatment facility partners. So it is also fire resistant. So we have specific wall components that is rated to up to 2 hours. And most importantly, it is cost effective actually. So our houses are about 20 to 30% lower than a conventional structure of the same type, like residential structures. If I'm not mistaken, the cost of our structures here at base, our latest project costs at about just 14,000 pesos per square meter. And from last I checked, the typical cost of a residential single-story residential structure is about 20 to 30 pesos, 20 to 30,000 pesos. So that's a significantly lower amount. So here, there's a short video showing you to show you the process on how our CBFT houses are made. So our CBFT houses starts with a typical foundation, like other structures. So it starts with a RC, a reinforced concrete foundation with just some exposed dowels. So those exposed rebars or dowels will come into play when we attach the prefabricated bamboo wall panels. Okay, so the flooring is being done. So now Foundation is ready to receive the wall panels. So the prefabricated wall panels are just placed inside the dowels. And then to fix those panels into the foundation, we just drill holes on the bamboo and then we mortar infill those holes, provide a stronger connection for the panels. Then once the panels are set, we place the purlins and then the roofing to protect the bamboo from the weather. And then we start with the finishes. We close up the walls, the claddings, then finishes. Yeah. So this is just a short animated video to show you how the CBFT houses are being built. And actually, this is a fun fact. Our houses, this whole process from foundation to finishes only takes about 5 weeks to be done. And the placement of the prefabricated wall panels are so easy it can be done by unskilled workers, untrained workers. Because we usually get some help from we get some helpers from the Hilti Corporation that go from their offices to the Philippines to help build these houses, and they can actually do the placement of the panels in like 4 days. So these are just these people are like office workers and they're not skilled workers. Okay, so here's another video just to show you how our CBFT houses perform under seismic load. So this is a shake table test conducted by the Universidad de los Andes in Colombia. So the demand that they used here is the Kobe, Japan earthquake of 1995 with a peak ground acceleration of 0.82 G and peak ground displacement of 17.7 cm. So here's how the CBFT house performs. So as you can see, majority of the damage that we can observe from this video is mostly just non-structural damage. There's no major damage, just some cracks falling off, cladding. So far, it's just non-structural. So this shows that our structures can withstand strong earthquakes. So another thing, so Base Bahay was founded back in 2014, and then we also constructed our pilot houses back then. So there were 3 pilot houses located in Bicol. And unfortunately, during the same year in 2014, Typhoon Glenda, it's a super typhoon, hit. And our site was directly in the path of the typhoon. And if I remember correctly, UPLB was also hit by this typhoon. And there's a lot of trees that were put down by this. So back in as you can see in the picture above, there's a circled house there. That's a Bahay Kubo. So the Bahay Kubo definitely did not withstand the typhoon. So I'm sorry, I don't remember the wind speeds that we were able to record there because there's a machine around. There's a device near these houses to measure the wind speed, but from what they told me about this incident is the winds were so strong, the device itself to measure the wind speed was blown away by the typhoon. But our houses itself stayed intact. So from the arrow on the other side, you can see there's the damage that the houses experienced were just non-structural damage in which the GI sheeting of the houses were just lifted a bit by the winds. That's it. So these 2 tests the full-scale test in the laboratory of Universidad de los Andes, and this full-scale test, actual test that happened in 2014, shows us that our CBFT houses is actually disaster resilient. So let's discuss the three arms of the BASE Innovation Center, and let's focus first on BASE. Oh, sorry, for BASE Bahay, three arms of BASE Bahay. So the first arm is BASE Innovates. It is the BASE Innovation Center was established back in 2021, and it focuses on four things: research and development, codes and standards, training and learning, and then international technology transfer. Okay, so for research and development, we do a lot of different research here in BASE Innovation Center. We do material characterization of different bamboo species. We do connection tests. We do full-scale wall panel tests. And then those tests give us insight on how we can develop or improve our existing codes and standards. So we also do for training and learning, we also do CPD programs. We train our students to do the tests themselves. And then for international technology transfer, we also dabble in international codes and standards, plus we accept international interns from different universities. So one of the things that we do here in the BASE Innovation Center is the characterization of mechanical properties that is used for structural design and standard. So as per the ISO standards, the recommended test for bamboo is just about 30 per test. So we do about 6 types of tests: compression parallel, tension parallel, bending perpendicular, shear parallel, tension perpendicular, and also bending parallel. For tension parallel, there are three different types. So in total, I think we do 8 tests, 8 types of tests for a complete characterization of a single bamboo species. So there are 30 tests required by ISO, but actually for BASE Innovation Center, we recommend doing 100 tests. So in total, we need about 800 tests for a full characterization of a single bamboo species. And currently, we have finished Hawaiian Tinik or Bambusa bulmiana. And we're currently working on improving the test protocol for mechanical properties just to reduce this 100 tests. But right now, we're doing tests for 4 other species: iron bamboo, golden bamboo, giant bamboo, and bayog. So other than mechanical material characterization, we also do connection tests. So for example, here, what you can see in the photo at the UTM is a Q connection. It is a doweled connection that is loaded perpendicular to the fiber of the bamboo. So we test this type of connection. This is actually mortar infilled. So we test these connections in the UTM, and then we process it, like we take the maximum or the yield values, and then we fit a line, a function for the mean, and then we take the characteristic values of those functions. And once we have the characteristic values, those are the values that we use for design, and those are the values that we give or use to develop the Philippine guidelines. Okay, if I haven't mentioned it yet, so recently, BASE Bahay Foundation, with the Association of Structural Engineers in the Philippines, ASEP, recently released the PH guidelines for the bamboo in the Philippines. So we actually have a CPD program here in our Makati office tomorrow for the recently launched guideline. Okay, so other than connections, this is just one of the few types of connections that we actually use in the CBFT houses. We also do large scale testing. like actual scale wall panel tests. So let's try to show the video here. So this is a shear test of a CBFT wall panel. So we're doing a shear test, and from the shear test, you can produce the hysteresis curve. And that hysteresis curve can then be used to produce something like what I showed you with the connections, the design values, the characteristic values that can be used for guidelines and codes. Okay. So without our partner institutions, actually, a lot of our experiments here, like from mechanical properties, connections, and wall panel testings, won't be done because here in Base Bahay, we're just a small group here. Like here in the office right now, we're less than 20. So we do have some partner universities, local and international, to help us do the studies. So for local universities, we have students from LaSalle, so this is UP Diliman, UP Diliman, UST, Mapua, TUP, and PUP. And we're also working on collaborating with UPLB and National University Manila and Ifugao State University. So for international university, we're working with Coventry, ETH Zurich, Virginia Tech, Universidad de Valle, Hong Kong University of Science and Technology, etc. So for other institutions, we worked with ARUP, INBAR, HACCP, Bamboo U. So as for the impact of the Base Innovation Center, so far since it has been established, we've been able to train 300 plus local and international interns. We've also able to do 91 student research, and then 12 published journals and 14 conference papers. We're also in the process of development of codes, guidelines, and manuals for different countries. So we have here the Philippines, Colombia, Fiji, Peru, and Nepal. So just as a fun fact, for ISO, we have 3 representatives for ISO here in our office. We have one for the Philippines, our head of the design team, Engineer Bembi Gohitia. And for Nepal, we have our head of the Base Innovation Center, Nishal P. Pradhan. He represents Nepal, and Luis Felipe Lopez, our general manager, represents Colombia. So there's a lot of representatives here in the Philippines for bamboo codes for ISO. So next is base builds. So for base builds, our work doesn't stop with research. We actually implement it on our different projects around the Philippines. And actually, we've also done some projects in Nepal and Sri Lanka. So here are some of the projects that we have done so far, but this is not limited to this list. This is just a few. So we've done some single-story duplex houses, some houses for indigenous people, and we'll also be able to do 2-story houses and a middle-class house. So these are for residential projects. So for the residential projects, there are a lot of options for the interior. We can do full cladding with the bamboo studs hidden, with the bamboo studs revealed. We have flattened bamboo, we have weaved bamboo. There's a lot of options. So we also do non-residential projects. We do community centers, office buildings in Batangas, school buildings, weaving centers, and food processing centers. And actually, we're currently working on a project to build, I think, a community center in BGC that is made of bamboo. So these projects won't be possible without our community partners. So we work with local government units and nonprofit organizations, local and international. Some of these might be familiar to you, like Gawad Galinga, Habitat for Humanity, All Hands and Hearts, and UN Habitat. We also work with social enterprise and private partners. Like for example, Kanya Kawayan and Kawayan Collective. These are our treatment facility partners. So other than base innovates and base builds, we also have base enables, in which we try to improve the bamboo value chain, starting from harvesting up to the construction site. So we've helped here in Base Bahay, we've helped. Okay. So here in Base Bahay, we've helped establish 9 different independent bamboo supply and treatment partners in the Philippines. We have one from Isabela, Nueva Ecija, Batangas, Negros Occidental, Negros Oriental, Davao, Cotabato, Palomonok, and Bukidnon. And we also have helped establishing treatment partners in Nepal and Sri Lanka. So summing up, this is the last slide. Our global impact and base innovation, Base Bahay Foundation is we've been able to build more than 2,000 houses with our cement bamboo frame technology, and we've been able to save 35,000 tons of carbon dioxide, with 10,000 individuals sheltered, with 3,000 more individuals trained since its establishment. Okay, so if you're curious, you can actually visit us in our Makati office. You can just contact me or contact info@Base Bahay. You can schedule a visit. And then I think that concludes my presentation for today. So sorry for the delay on the presentation earlier. So that's it.
No worries, sir. And let us give Engineer Gabriel Antonio I. Pimentel our round of applause, our virtual round of applause. Thank you, sir. And if you have questions, I think you have a lot of questions for our first speaker, for Engineer Pimentel. Please reserve them for later in our Q&A session. We will have a dedicated session for that. And reminder to our participants, you are requested to fill up our attendance, which is in our chat. Again, thank you, Engineer Gabriel Antonio I. Pimentel.
Thank you.
We're requesting you, sir, to please remain with us until later for our Q&A session.
Sure.
Thank you, sir. Okay, so we'll now proceed to our second speaker. Our second resource speaker from Holcim Philippines Incorporated is Engineer Samuel Manlosa Jr. He is a senior vice president. He's a senior vice president and head of Geocycle at Holcim Philippines, where he leads the company's waste management and co-processing business. In this role, he has been instrumental in embedding sustainability and circular economy principles into the core of Holcim's cement manufacturing strategy. Through his leadership, Geocycle has significantly expanded its partnerships with local governments and industrial sectors, driving synergies that support both decarbonization and the diversion of waste from landfills through alternative fuel use. Sam is actively involved in shaping policy dialogue around sustainable industry practices in the Philippines. He has worked closely with the national government agencies to promote the role of private sector innovation in solving pressing challenges, including solid waste management and climate resilience. Prior to leading Geocycle, Sam served as plant manager of Holcim Davao from 2020 to 2023. Over his 15-year career with Holcim, he has held various regional and group level roles in industrial performance, process optimization, and operations management, consistently championing the integration of sustainability with operational excellence. Friends and guests, let us all welcome Engineer Sam Manlosa Jr. from Holcim Philippines Incorporated. Let us give him our virtual round of applause.
Good morning, everyone.
Good morning, sir.
Morning, Edward. Let me just share my slides.
Go ahead, sir.
Yep. So while I'm sharing my slides, allow me just to make a couple of segues dun sa presentation ni Gabriel. No? So, Holcim is actually in bits and pieces on certain projects working with Base Bahay. And I think that speaks to the broader important narrative about doing a concerted effort on sustainable construction in general. Given the scale and size of the problem, I'm sure everybody would agree that no single company entity can solve it uh, without the aid of other agents. And it's also an interplay of policy and technical innovation that's going to drive sustainable construction forward. And the second part is particularly interesting kasi Engineer Gabriel mentioned earlier na we don't have a framework for bamboo as a structural material. That's true. But I'm also aware that at least one congressman or somebody in Congress is actively working to enact a bamboo-focused bill that will allow bamboo to be a qualified structural material given certain constraints, of course. And yun nga, the interplay of technological innovation together with policy, it is really what's critical in order to drive sustainable construction. And without that, we'll be stuck where we are, especially given the nature of the Philippines per se, and then the nature of construction in general, which leads me to the topic I want to talk about today. So what I have is I would call it a fairly generic slide. Given the number of participants, I see there's 189 people logged into the call. It would be very difficult to create a presentation that's going to cater to specific needs that people want to know about. So I'm probably gonna touch bits and pieces of the whole value chain on cement. And then I'm gonna spend some time talking about geocycle because I understand people want to get to know more what innovation the cement industry is doing to decarbonize. So to set that up, you would know fairly well, and see Engineer Gabriel also alluded to it earlier, that cement is one of the most it's one of the higher contributors for CO2 emissions. Be it in construction or in industry or in power consumption. So cement is one of those industries where if you want to talk about decarbonization, there's a lot of potential in the industry that we can realize. And then, so given that, it's important for cement companies and the cement industry in general to realize that role. You can always think of it as a problem, which I think some traditionalists would like to think na yun nga, cement is polluting, etc. But also you can look at it as an opportunity. Again, I go back to this idea of policy and technology coming together to be able to solve a problem. So in cement, we are actively working to decarbonize the cement industry in general. So you would be familiar from your ESG, no? So we're talking about scope 1, scope 2, scope 3 emissions. And today I will touch more on scope 1 and scope 2 we can touch if you want to talk about it a bit more. But scope 1 is generally where there's a lot of potential to be realized. Now, the caveat here, or at least the base discussion is fairly simple. Until we find a suitable alternative to cement as a construction material, we need to put a lot of effort into really decarbonizing cement. So why is that? Because, and this is a cliche, but maybe it bears repeating, next to water, cement is the most readily used material worldwide. Civil engineers would tend to quote that also fairly regularly. We have not found as a species, as a technology, a suitable replacement to cement. So given that, then we need to make do with what we have. And it's really important to focus on that. So cement, as you would know, yes,
Sir,
Edward?
I hate to interrupt, but some of
Sure.
your slides are not. I think the meeting controls are blocking some of your slides.
I actually don't. So my slides look clean from my end.
I think on the right side, sir, some parts are blocked. I think these are the
You
meeting
mean like
controls.
this?
Once you,
Is that better?
yes, sir, the ones. That's better, sir.
Okay, it's actually the it's the video it's the
Okay, sir.
anyway. So yeah, so I've
It's okay now,
minimized
sir.
it.
You may proceed, sir.
Sure. So where was I? So cement, we've not found a suitable material to replace cement in industry, in construction, and in general daily use. And I think if you forecast where the global trends are heading and how it is going to uh, need a backbone for building what's going to happen or where civilization is going in the next 50 years, the pressure to really do something about decarbonizing cement and making it more environmentally compatible is very, very high. So in Holcim, we embrace this opportunity, I would say. We've made firm commitments across the global stage. You can Google what Holcim is doing on that front. But we strongly believe that cement can be decarbonized. It requires a lot of effort, but that's true for anything involving decarbonization. And the story that I would always want to talk about is that this growth of solar energy. You would remember maybe 20 to 25 years back, the price of solar panels is about 20 times more than what it is today. So we've shaved the price per panel to about 5% of where it was about 20 to 25 years ago. But what did it take? It took a lot of investments. It took a lot of hard work on governments and people investing and businesses folding and a lot of criticism, and even land use can be a debate when it comes to solar. But there's no denying that if you continue to put effort into a technology that you believe can solve a problem, then the problem can be solved. And in cement, I think the story is the same. So there are a lot of innovations that would hopefully someday be a good substitute for cement. For example, I point to in Holcim now we have examples of 3D printed concrete that has been used to do to carry light structural loads. So it's not yet at the level where you can scale it significantly, but it's definitely at the level where it can be a structural substitute to lighter load installations and buildings. So that innovation is progressing in that regard, but until we get to that point, the base technology, which is cement itself, needs to also be decarbonized. So I go back, global trends, population growth, we're only going to continue to have more people. I think forecasts say that the population of the world will peak by 2100, maybe a little bit after that. So from now until 2100, we have a moral obligation as a society to make sure that there's equitable distribution of resources and people get access to the same advantages and benefits and social benefits that all of us currently enjoy. So we need to continue building. And more than that, urbanization, I commonly say this whenever I'm given the opportunity to speak. I think most of us in the call were not born in cities, but eventually we moved to cities. So I currently am based in Manila. I'm sure many people in the call can relate to the same story, being born in the province and moving to the city. And that's not going to change, which means the cities need to continue to grow bigger. They need to become more efficient to handle more people. And how are you going to do that? You have to build, and you have to build responsibly. And then on top of that, you layer on the challenges of global warming, resource scarcity, the growing problem on waste. So all of these things, there is a point where they need to intersect, and that intersection needs to become an opportunity for businesses, and cement in particular. So that's why we are here today. So actions that are needed from our perspective, again, we can talk about many more details, but I point to 3 that are crucial. Landfills contribute about 20% of total greenhouse gas emissions. Whenever you talk about waste, especially the common person, we have this mentality where if it's out of sight, it's out of mind. And more often than not, we don't care about waste segregation and sorting because we believe there are 2 reasons. Firstly, we believe that somebody is going to do it for us down the line, or we believe that our actions are not really contributing to any more harm than what it is doing. And both of those actions are false. So the moment the material gets to the landfill, and when it's done in a way that's not responsible and proper, you're only going to escalate greenhouse gas emissions. That's a given. And then human consumptions, we continue to eat more, consume more. Our culture today of, Lazada and Shopee and Zalora and Shein or whatever it is that you subscribe to, only feeds the need for more generation of material, which then consumes a lot of resources. There's a concept called the World Overshoot Day. So the World Overshoot Day is basically the ratio of resources that can be produced in a year relative to how much resource we consume in a year. And you can express that in the form of a calendar. And today, the World Overshoot Day is about July 28, July 29, which means that by July 29 of any given calendar year, we've already fully consumed as a civilization and as a species all of the resources that are supposed to be produced in that year. And then we borrow from the next year. So we're consuming the equivalent of 1.7 Earths every year, and that's not sustainable. And then, of course, when you produce more waste, which goes to the soil, water, etc., creating social issues. So you know the scale of the problem. I don't need to belabor that point. So the opportunity that we see in Holcim, so I mentioned that cement is doing a lot of initiatives and levers in order to decarbonize. So we can talk about clinker factor, for example, how much clinker goes into cement for those who are familiar with that. But one of the key things that we really look at is transforming wastes into resource. No? So the philosophy is that it's not really waste until it's already on the ground and it's thrown. And even then, you can still recover it as a resource. We believe that trash, basura, can still find a second purpose. Of course, to do that, it requires a lot of intermediate steps. And then I go back to personal reflection. So what do you do with your waste? Do you segregate? If you don't segregate, if all of your organics go with your plastic packaging, with everything that you buy in the kitchen, if all of them go together into one bin, imagine that to make your waste useful, to transform it as a resource, somebody has to actually come in and exert effort and put energy into segregating and separating your waste. So that has to be done right now because we're not yet at the level where we're able to responsibly do that. But then again, the work has to be done in that aspect. So when we say transforming waste into resource, we believe, and again, this is cliche, but I think it is important to emphasize. So we want to look at reduction of consumption, which means basically being more efficient. And in industry, in cement, one of the things that we closely monitor is how much energy you consume to produce 1 ton of material. That's a very heavy point of emphasis that we discuss on a daily basis. So you can talk about different types of energy. Is it power? Is it fuel? Is it a ton of raw material? So whatever it is, the measure is to try to find a way to reduce wastage and to make your process as efficient as possible to produce 1 ton of material. So remember, the 1 ton which you use for construction is non-negotiable. But all of the inputs going into the 1 ton can be optimized and improved. And that's what we're trying to do. The second one is recycling. So this is obvious. A material needs to have repetitive number of uses. So how many cycles does it go through before it is fully disposed? And that's really important. Many in our current daily use are basically single-use materials. So you hear a lot about single-use plastics. They're only made for one purpose and one use, and then you discard. But the whole idea of being more efficient and optimized really relies heavily on the number of cycles that you can use that material to be able before it becomes fully discarded. So that's circular economy. And then recovery. So here is where GeoCycle plays a part. So inevitably, you will have materials that would have arrived at the point where they cannot be recycled and reused anymore, or you have materials that really are single use by design and the only option that you have is to throw them away. So recovery is the idea of finding a second purpose for these materials, making sure that instead of them serving just the one purpose, packaging, etc., you need to be able to transform them into something else And preferably that something else has to substitute something in the process which has been there before. So let's say in our case, it's fuel. So the cement industry from 100 years ago was designed around the use of traditional fuels like coal. Today, more and more of the energy that we use to manufacture cement comes from waste. It offsets the use of coal. So if you look at the total consumption of the cement industry for coal, it's coming down every single year, and the use of waste as a resource is going up every year. So that's the whole point around recovery. Altogether, this is where we close the loop. No? So circular economy in action is how it looks like. You want to reduce, you want to recycle and create many cycles out of a material, and you want to recover. Whatever comes out of that circle needs to have a second purpose in order for it to be truly useful. So in our case, so GeoCycle, maybe I will touch on it a little bit. What we do is we sustainably transform waste into something else. And in our case, it can be either as a fuel or as a raw material. And we work with not only national regulatory agencies, but you can also look at how global policymakers view what we do in general. So GeoCycle is the global brand of Holcim that focuses exclusively on making waste into a fuel or into a resource. We pride on the technology being a high energy recovery process. So let's say if your material has inherent calorific value in the form of plastics, we use that to our advantage, and we use it to make sure we avoid the use of coal. It's also 100% recycling, meaning we do not generate any waste out of the process. So when you feed waste as a fuel into the cement manufacturing process, there's no residue that comes out. Everything that comes out is fully integrated and utilized as a material. And then, of course, carbon intensities matter. So if you burn 1 ton of coal to fuel the process, the CO2 emissions of that is much higher than many other types of materials that we have. So your net CO2 emission per ton of material that you consume ends up being lower, plus offsetting materials that go to the landfill. So the landfill, one of the problematic issues with the landfill is if decomposition is uncontrolled, then you don't only generate CO2, you generate methane, which is infinitely more, has higher global warming potential than CO2. So that is also critical. Avoiding materials from going into the landfill allows you to control the generation of greenhouse gases in a better way. And then, of course, it's utilizing existing utilities. So we don't we try to make sure that with minimal investments, we recover what is existing. We work with LGUs. There's a lot of work that goes behind that. We talk to mayors, Menros, Penros, and understand their waste problem, and then try to devise solutions around that, which allows us to achieve a win-win situation with the LGUs, with industries, and the cement industry in general towards sustainability. So this is how it would look like, just very general process flow. So you start with the one on the left. So basically, GeoCycle services, or at least what we do, encompasses a lot of streams. We can take it directly from source, which means after it leaves your household, the municipal solid waste, after the municipal solid waste leaves your household, it goes into a facility where some degree of sorting and segregation can be done. You would not believe how poor the waste management system in the Philippines is until you see it for yourself. But basically, we do not have any large-scale sorting and segregation systems that exist in the country. Nowhere. And I've toured the whole country, and I've seen enough to know that we can significantly improve in that aspect. I've also seen how other countries do it, and we're really, really far behind. So our interim solution, what do the LGUs do? The LGUs actually put a lot of manpower into waste sorting and segregation. So I go back to this concept earlier about when we are not responsible with our waste, somebody needs to sort it for us. And that person who has to do the sorting for us, you would know who these are. These are waste sorters, informal waste pickers, the economy around recycling, and people that are picking waste. we're making their lives infinitely more difficult when you mix organic waste and waste that can be repurposed and reused. Waste is already dirty enough as it is, but our own personal decisions that we don't even think about significantly impact the lives of these people on a daily basis. If your wastes are cleaner, they're better segregated and sorted, their job becomes easier. But because we don't take that decision actively, they're suffering on our behalf. So just maybe something that you can take away from this talk. So once the waste leaves your house, it goes to a facility where it gets sorted and segregated manually. And then each of those streams go to their respective uses. In the traditional model, actually, no sorting and segregation happens. Everything goes to the landfill. In the model that we're trying to push, each stream gets its own process flow and gets used in the most optimal way. So the recyclables need to go to recyclers. You need to make sure that you recover the value out of the recyclables, and only the ones that cannot be recycled eventually find their way into Holcim plants. And with everything that we do, from the efficiency on energy, lowering energy consumption, finding alternative materials that have lower CO2 intensities, using fuels that have lower CO2 intensities, offsetting the use of traditional fuels, all of that scope 1, 2, 3 is what eventually feeds into construction. So what Engineer Gabriel was talking about earlier. The cement CO2 intensity today is at least 30 to 40% lower than where it was 10 years ago. So we've made a lot of strides in the industry. What we used to think as heavily, CO2 intensive still is CO2 intensive, but it has come down significantly. And there is a lot more potential for that to continue. But again, with scale and with complexity, you need then to put a lot more resources, technology, innovation, automation to make sure that becomes sustainable. But the end goal is the same. We will continue to build cities. We will continue to create buildings, infrastructure, but we do it in a more responsible and sustainable way. You will see here basically so the technology is called co-processing. So it's the one in the middle. And we sit right at the crux of what we feel is, how do I say this? So we're making ourselves a last resort, basically. So you always want to reduce. Prevention of consumption is always the best and most desirable method for waste management. If you cannot prevent or reduce, you reuse. You create many cycles out of one material instead of having it be single use. And then once that's done and it gets to the end of its life, you decide, how can I recycle this, upcycle, make it into something else? So it finds a second purpose. And then only then do we come in. So if all of the previous steps are already exhausted and the material really needs to be thrown, that's where co-processing can be a viable alternative. So instead of the material sitting and decomposing somewhere, it gets one last purpose to be able to generate energy for a material that we need to produce anyway. And then below that, you would have incineration, you would have landfilling. And then in the Philippines, what we call landfills are typically open dump sites most of the time. And this would be uncontrolled. Some people burn it, they get dumped everywhere. There's no control of leach generation. So a lot of this then becomes a major environmental issue that is left unregulated and uncontrolled. And maybe quickly just to touch on that. So some people actually think what we do is incineration. It's a fair comment, but there's more that goes behind it. So at the end of the day, whatever we do with the waste, remember that the most important parameter for us is still the quality of the cement that comes out. That's still the most important. At the end of the day, our business is to produce cement. So whatever you input, however you input it, you need to make sure that that process does not disrupt the cement manufacturing process. So which is why it's called co-processing. You want to do two things with one process. You want to produce cement and also recover energy from certain materials without changing the outcome. Incineration is a much more simple process where your whole purpose is just an elimination exercise. You have a material, you subject it to high temperature, you expect it to be gone after it is burned. That's it. So the controls that you put into it, what happens after the combustion process, the waste that you get to produce after. So there's a lot of ashes that come out of it. It's a separate problem. But in our case, so the cement manufacturing process is already inherently a very thermally intensive process. So we operate our kilns at more than 1,500 degrees. And then we use that process already in action to be able to generate the energy coming from the material. So it's a two-in-one process, treating the waste while making sure you produce cement. And again, at the end of the day, our commitment is that you as a customer, you won't even realize that upstream processes have happened for you to get your cement. The quality remains the same. You comply with PNS, you comply with the BPS regulations, you comply with whatever DTI sets as a standard, nothing changes. So there's a lot more technological innovation and process control that needs to happen behind it. We have facilities all over the world. We can treat different types of waste. And as I mentioned, it's really important that every type of waste gets its own treatment process and recovery process very, very specifically. You cannot just lump wastes and assume that they're going to be treated the same way. That's crucial. Every type of waste contains different types of chemicals. Calorific values are different, moisture levels are different. If you want to maintain control of your process, you want to make sure that all of your inputs are tightly regulated. And in all of this, we follow very strict health, safety, and environmental standards to make sure that everything remains compliant. So one thing that I always say is this, because there's always going to be questions. So when you co-process municipal solid waste, for example, does that change your emission characteristics? Do you produce more CO2? So what happens in cement? So what happens in your operations? Our operations in Holcim have continuous emission monitoring systems. So for every second that ticks, one data point is taken out of the effluent stream. One data point on one specific parameter, and you monitor like 15 different parameters. So everything from NOx to SOx to VOX, CO, CO2, oxygen levels, moisture. So there's a whole spectrum of materials that you monitor. And it's called continuous emission monitoring system. That continuous emission monitoring system is automatically linked to Department of Environment and Natural Resources. So whatever data that we see, they see in real time. And that really is important because you need to ensure that in the process of trying to be sustainable and trying to decarbonize, you continue to keep within regulatory standards on emissions and on other parameters, water, waste management. All of that needs to be maintained. And in our case, the NREMB has complete visibility of the data that we have. And you need to make sure that you're really operating at peak levels and everything is working well. For you to sleep soundly at night, knowing that all of that data that you generate also goes to the regulators. So just keep that in mind because that's really important. And then, these are some of our partners. I don't really want to go through this because if you have questions, I'd be more than happy to answer. And we continue to work with a large slice of the industry. So what's really important is this. For industry, so every single product that you consume, so here we have, just to mention a few, Nestle, Coca-Cola, every single product that you consume generates some form of waste unavoidably. And for those industries, so a lot of those industries are also equally committed to making their processes sustainable and to decarbonize. But you also need to remember that in some of these cases, their ability to dispose waste is limited by what's available in the, as an option to them. And that's where we come in. So given that our process is very tightly regulated, you have your emissions tightly monitored, controlled, these companies can then work with us, among others, to make sure that their wastes are disposed responsibly. And not only that the waste that they dispose finds, as I mentioned earlier, finds a second purpose before it is actually completely destructed. That's really critical. So we always believe you can see the comment there, giving discarded tiles a second life. So we really strongly believe that every material needs to find a second purpose before it truly gets destroyed or disposed. And I already mentioned we have a decarbonization commitment. We're signed up to SBTi, science-based standards on CO2 emissions. Our performance indicators are all tied to our commitments on the environment. And we believe that a net zero on cement is attainable by 2050. We have a lot of innovations that are happening all across the world. In the Philippines, we're leading some of those innovations, but we're also copying with pride from other countries who are also doing equally well. Our one of the goals that we have in the Philippines, for example, is that in the next 6 years, more than half of our fuel consumption will be from waste. And our dependence on traditional fuels will continue to come down and come down. But at least for the next, not 6 years, 5 years, by 2030, we should be at least 60% of energy input coming from alternative fuels. So we firmly believe that that's a doable objective. It requires a lot of work, but by doing that, we continue to make cement a viable resource for future generations because we continue to make it more sustainable with lower carbon footprint, so people can continue to build with the same strong type of material, but also at the same time feel that they are doing it in a responsible way. So I think that's the presentation. I'm willing to talk about, if you have any questions, technical, policy, let me know. I'd be more than happy to answer them. Thank you, Edward.
Thank you very much, Engineer Manlosa. And please stay with us. Again, and let's give him our virtual round of applause. And Engineer Manlosa, please stay with us because we will shortly begin our question and answer portion. Again, we are requested, our audience, our 193 strong audience, and I think we have audience not only from UPLB, but also other universities. I'm seeing other university students, I presume, present here in our Zoom webinar. Okay? And please again use your question and answer tab for our questions. You may send your questions anonymously. You have the option there. And I think our speakers are now ready, Engineer Pimentel and Engineer Manlosa. Are you ready to take our questions from our audience?
Sure.
So let me start with this anonymous question for Engineer Manlosa. So the question goes, in addition to decarbonization, how does the cement industry protect biodiversity despite it being a heavily extractive industry?
Yeah, good question. Our quarries, so they are also, you would know, they're also very heavily regulated. And I think for those who are familiar with how MGB operates and how the quarrying mining industry works, before you can make any single step, so I start with the value chain. I start at the beginning. Before you can put any shovel on the ground and extract, one piece of material, you have to go through this whole bureaucratic process of getting permits, and you get site assessments, and even if most people would know this, for just to get the permit to cut one single tree, you need to replant how many trees to offset one tree that you cut. So I'm not sure people know the number. So normally it's 100 trees for every one tree that you cut. You don't get the permits if you don't comply with that. So that's at the beginning. Before you even do anything, you need to make sure that there's a proper plan in place for extraction. And then after that, there's also this whole process about quarry rehabilitation and biodiversity surveys every 2 years. So the MGB and DNR is very strict with biodiversity audits and biodiversity compliance. In Holcim, actually, every year we conduct biodiversity audits every year, and we measure critical indicative species for certain areas. So it depends on where you are. And you need to make sure that when you're seeing your annual audits produce results that start to impact biodiversity, you need to have the appropriate actions in place to offset them. There was actually one thing. So when I was plant manager in Davao, one of the things that we celebrated was, so the Davao plant for us has been there since about late 60s. So you can imagine the footprint has been for about 60 years now. And there are big parts of the quarry through the quarry rehabilitation plan that we've established that are already back to, I would say, not really normal, but they've heavily forested already. And in one specific case, one of the highlights of my being plant manager in Davao was we observed the famous monkey-eating eagle in Davao nest in one of the rehab areas for the quarry. And to us, that's really a big moment because it shows that, yes, it's extractive. Yes, for a while, you will have a footprint. We argue that you can minimize, but you can't really avoid. But what's important is once you're done with the work that you're supposed to do, how do you turn the area over to make sure that it gets the best chance of being restored to what it once was? A lot of work, but I think that is a good example that shows, yes, it can work if you really do it the right way.
Thank you, sir. And just a follow-up, and this will be coming from me. How long does it take for it to be not anymore
Open and
how
barren.
long how long does it take? Yes, how long does it take? What is it span of years, decades? How long does it take? In
Yeah.
your example in Davao, how long did it take for it to be extracted fully, and then afterwards you rehabilitated the area?
So the length of extraction depends on how much material is on the ground. And actually, it's preferable when you have a site that has higher material density. So for example, in our case, limestone, right? When you look at deposits, you would prefer deposits that have a lot more tonnage in a really small area because you can contain your impact within a small area. The consequence then of that is you utilize the area for longer because it takes longer to extract the resources. I prefer that, and we prefer that, over a setup where the limestone is just under the overburden, but then it's just a few meters thick, because it means you need to cover a wide amount of area to use the amount of resources. So the extraction part varies from area to area. But once you extract, so normally we say the area is fully depleted. So within a year, you need to start rehabbing, at least in our internal policy. In MGB, I think you need about 2 to 3 years, then you can start rehabbing. But for us, once we declare an area as mined out, quarried out, you rehab within 1 year. And then you need to be mindful of the strategy, which is a very good question. How long does it take for it to be forested? That actually is easy. You can always plant trees that grow fast, then it gets forested quickly. But maybe those are not the types of trees that you want to plant, because those might not be the types of trees that are good for the area, or they don't last very long because anyway they fall down after 5 years. You need to create in your quarry rehab plan, you need to declare what types of trees you're planting and why you're planting each of those specific species, just to cover certain things. So if you want to restore biodiversity, certain types of trees suit certain areas. If you want to reforest an area very quickly to prevent soil erosion, fast-growing trees matter a lot. Then you put a percentage in fast-growing trees and a certain percentage for biodiversity. It's a lot of work. There's a lot of science. I'm sure the foresters in the call would know. But generally within 5 to 7 years, the area is already green. Generally.
Thank you, sir. And I think we had the thumbs up there from our department from the College of Forestry and Natural Resources. I think there was an affirmation there. Thank you, sir. We have another question here from Mr. Obsequio for Engineer Pimentel. Question on Bamboo House: can it replace container van offices? And second, how does it perform with air conditioning? Go ahead, sir.
Well, for container van offices, I'm not sure about it because but we've been able to do offices itself, but for air conditioning, I haven't seen any projects that implemented air conditioning yet. But this is interesting actually, because we are currently trying to research more about the thermal effects of our bamboo houses. And from our recent studies about this is our bamboo houses during the daytime performs similar to reinforced concrete houses as well, but it cools faster during the evening. But for air conditioning itself, maybe it can be applied, but for our current housing projects, we don't do air conditioning because these are in the provinces.
Thank you, sir.
Does
And
that answer the
I think
question?
that was answered, sir. And I think in addition to that, Are there, you've said earlier that there are now codes. I think you mentioned some
Yeah.
standards for bamboo construction. Is there a provision,
So
are there provisions there, sir, for energy audit of these houses? I think the Department of Energy has set in place policies on energy audit. Does it also apply to bamboo houses?
right now, I don't think there's provisions for that. The bamboo guidelines that we did mostly just cover the structural part of the bamboo houses. It's the
Thank you, sir.
one with it's the
Mhm.
standard that we did in collaboration with Asset.
Okay, thank you, sir. And another question for Engineer Pimentel. Here we have an anonymous participant who raised the question on what is your biggest problem encountered in terms of raw materials, implementation, or expansion? And what can be the role of research, policies, and probably collaboration in helping our communities achieve more efficient housing? So it's touching
It's a big
Mano's
question, yeah.
area. So, yes, sir. Go ahead.
So let's start with the first question. Okay, so the first part of the question is what's our biggest problem in terms of raw materials? So
Mhm.
for bamboos itself, for the bamboo materials, we don't have much problem with those because we have
Mhm.
our independent treatment partners
Mhm.
that provide the bamboo to us. And then for implementation or expansion and the goals of research, like from the video, actually from the video that I showed earlier, our process is a little bit more refined than the video. So we continually try to improve our CBFD houses. Like we try to do most of it in a prefabrication centers. And then also we also try to we try to innovate in our connections. Like for example, I'm working on a project right now to try to completely eliminate mortar infill in our dowel connections. So we're trying to replace those to have a lesser carbon footprint for some of our wall panels. So those types of research tries gives helps us into achieving more efficient housing in general. So we're trying continually to improve our our cement bamboo frame technology.
Thank you, sir. And in addition
So
to the question on, yes, sir, go ahead.
So for the second part, admittedly for the last part, I don't have much of an answer for that right now because
Mhm.
it covers agriculture as well. So mostly we
Mhm.
just handle the structural part. Maybe I can look on it. I can look on it more, and then the participant can ask me through email, so I can I can discuss on it later. But for the existing laws and ordinance that hinder our full implementation is mostly, the problem, our gap here is there, like I mentioned earlier, there's no existing provision for bamboos here in the Philippines, but we're currently working on that with ASEP.
Thank you, sir. I think the second question may be also directed to Engineer Manlosa on having existing laws, ordinances. What are the gaps on um, on the implementation of these policies? And also, based on your personal opinion, what are the biggest contributors of methane gas emissions? So you have mentioned, sir, of methane emissions in, I think, in landfills. Is it agricultural? Is it household waste? You mentioned, sir, of the how bad our waste management is at the municipal level. Go ahead, sir.
Yeah, so it's a bit of a complex problem. Let me start with policy. So for I'm very sure that the government, so Congress in particular, now we've had the chance to sit with many so the Committee on Sustainability and Environment in Congress several times on different legislative priorities. One of it is definitely decarbonizing industries in the Philippines. There's a lot of push towards that because, as you would know, we made commitments on CO2 emissions. A lot of it is conditional. About 72% of the commitments that we made on CO2 emissions is conditional on foreign financial support. But still, for the most part, I think there's a genuine effort to decarbonize industries in the Philippines. And that's not only DNR, DOE has a roadmap for renewables, et cetera, et cetera. But there are challenges, I would say. So the first one is Congress is currently still, I would say, working on big ticket items. And there are innovations that can more often than not be stifled by lack of regulatory oversight and focus. So I give you an example. So for the civil engineers in the room, how much do you need to depend on ordinary Portland cement to do your construction? You would know that most government projects today still specify OPC as a cement of choice now. But you only really need to do that in certain applications. In many applications, you can use much better lower CO2 footprint cement alternatives that do not need to be OPC. But because we don't have very clear regulatory oversight, not only that, the government, the primary consumer still uses OPC. You're going to have to be forced to continue producing OPC when alternatives are available. I'm not saying you phase out OPC. I'm saying there's always a way to optimize the amount we produce and the usage that currently exists in the market. So that's one. And then general on decarbonization, I think there are a lot of good practices from different countries and jurisdictions. So the EU, Japan have very good practices in place on decarbonization and industries. The problem is that there are specific circumstances in the Philippines that prevent us from copying directly those practices. For example, the market on CO2 emissions in the Philippines is quite small. So if you want to do CO2 emissions trading within just companies in the Philippines, that can be a bit problematic. So how much of the Philippine businesses classify as medium to small, medium enterprises? It's roughly around 97 to 98%, depends on who you ask. Meaning, at max, 2% of Philippine businesses are big industries, and those industries are the ones that qualify for emissions trading. So if you're only working with a very small pool of individuals that can do CO2 emissions trading, that really creates some problems because you don't have, economies of scale, you don't have typical market supply dynamics, etc., etc. That. And then agriculture, so yung methane, it's really true. Your organic waste, if it's not processed properly, becomes one of the biggest contributors to methane emissions because that comes from non-oxidative decomposition processes. No? And in many cases, in uncontrolled landfills, that is often the case. But maybe to create hope then, because I don't want to be just doom and gloom, there are actually cities in the Philippines who are working with waste management contractors who are farther ahead in managing organic waste and creating value streams out of it. So we know of a waste management company based in Cebu who serves Naga, Mandaue, who has a dedicated biogas plant just for that. So when the waste arrives in their plant, they already have a very clear plan. This type of material goes here. It becomes RDF or it becomes, whatever it is. This stream is recycled. The organics go into a biodigester, which produces biogas. The current question there, which is where the interplay of policies come in, is then they need to be able to build a power plant that utilizes biogas as a fuel, and they need to be able to sell competitively to the market to make sure that that value stream remains viable as a business. So that part is a work in progress, but you can see the innovation. The problem is this is just one out of the whole country. And absent, any push or support, you will continue to have, organics going into, common sa atin, composters. But composters are very small and they don't treat many types of waste. Shells, for example, from seafood, decompose a very, very long time. And it chokes the digesters for barangays. We've seen this in action. So there has to be a better push because the degree of uncontrolled organic decomposition creating methane can be alarming in the future. Right now, maybe not so much, but as we continue to grow and as we continue to produce more food and food waste, that will really become a problem.
Thank you, sir. And I think the government is keeping up. Recently, the Department of Energy has issued general framework for carbon credits. That has a long way to go, but still, that's a start, at least for as a broad policy for um, carbon credits.
Our position actually with carbon credits, no, with the policy regulators is, so yes, there are problems, and yes, there are specific situations in the Philippines that prevent us from copying directly, but we will not really know what works until we try. So that's our position with them. So let's try something, let's do something. As long as we can always talk about it in a way that allows us to retrofit the system if needed and make improvements to the processes, I think that's a good step rather than to just say, wag na muna, no, let's stand pat and not do anything. So I like where we are going, but we will have big challenges that we need to resolve in the next coming years to make carbon trading a viable solution.
Thank you, sir. A lot of challenges ahead, but we need to try. Thank you,
Yes.
sir. We have a lot of interest in the room for our base bahay bamboo. A question here is there a pre-treatment for bamboo use in base bahay, or are they straight from nature? Additionally, I think you have answered this earlier, Engineer Pimentel. Does base bahay have plantations for bamboos being used for the houses?
Yes, so I'd like to answer this one, and there's a similar question to this as well. And anonymous
Mm.
participant 1134 is
Yes,
susceptibility
sir.
to mold and fungal attack. So for base bahay, since we have treatment partners, we give them a framework of how bamboo should be treated according to existing code, international code. So we have a 9-step treatment process. And so I'll go through the steps. So first step is the receiving of the raw poles from the sites, from the harvesting site, and then we clean it, we scrub it, then we punch the nodes because bamboo has nodes, right? In between its segments. After punching the nodes, we wash it continuously for 3 days to remove the starch because the starch is what the insects typically consume, right? So we wash it and then we dry it again, and then we go through another round of quality control to check for cracks if the bamboo can be used structurally. And then finally, for step 7, we do treatment. So for the treatment of the bamboo, this prevents the fungal attacks, the insect attacks, infestation, etc. So we currently use for some of our treatment partners, we use a Solignum. I think it's a permethrin-based solution, and we also use borax boric acid solutions. We're currently researching as well, trying to use copper azole. But yeah, after treatment, we do drying again, and then after drying, we rack it for grading. So for some of the harvested bamboo that is like cracked or has some damage, we don't discard it. We actually use it for other purposes. Okay, so I guess that answers questions about treatment.
Thank you, sir. And in relation to that, you've given answers on the treatment. Now, some questions raised here are about empowering local communities. So, how can local communities be empowered to take the lead in bamboo-based construction, and how do they support or so that there will be initiatives not only for carbon emission reduction, but also supporting the
Yeah.
livelihood and cultural identity of those communities? Go ahead,
Okay,
sir.
so this is a good question. So it goes again to my point regarding how base enables local communities. So yes, we support the farmers themselves, the ones who harvest the bamboos by establishing the treatment centers. And then those treatment centers also produce jobs by extension. And then our various projects around the Philippines also help community. So, but I think I saw a question here regarding how our bamboo structures can be constructed. Where is it?
I think the local skills, sir. Local skills,
Yeah.
tools, and resources
So for
to
local
support
skills,
bamboo-based housing.
tools,
Yes, sir.
and resources, actually for the tools itself, we don't need any special tools to construct the bamboo houses. But we do have a fabrication table that just uh, uh, allows us to build the panels faster. So for individuals who want to try to construct our CBFT panels, we are actually releasing a manual on bamboo construction aside from the PH guidelines. So anyone, any builder, architect, engineer can try to construct CBFT houses.
Thank you, sir. And I think we have another question here again on bamboo. What policy measures and incentives can encourage sustainable cultivation, treatment, processing as an alternative construction? And maybe we can also insert the question on acceptability. If you say, sir, that this is alternative and a better alternative, how come that it is not yet that widespread use in the construction industry? Is there a barrier here on acceptability of the use of bamboo versus other
Yeah,
materials, more conventional
actually,
materials?
I discussed this earlier. Like there's a perception, like just not in the Philippines, like in other countries as well, that when we say bamboo houses, we typically think of bahay kubo. Like before I worked in base bahay, that's what I thought. So when we say bamboo houses, some people immediately think that it's not structurally safe, it's cheap, etc. You get my point? But
Yes, sir.
in other countries like Colombia, they have established bamboo codes. I don't think that's the case. So I think the problem here is more on the perception regarding bamboo houses, and that's what we're trying to change here in Base Bahay. So this is something that we're currently working on. That's why we're working continuously in developing codes, standards, manuals, etc.
Thank you, sir. And maybe as parting words, we don't have any more questions. I think we've answered all the questions. As parting words to our audience, we not only have engineers in the room, we also have people from the humanities. We also have people from other universities. What can universities, what can students, what can our education sector, at least our students in college can contribute to your initiatives. May we start with Engineer Manlosa. Sir, you have the floor.
I'm smiling kasi so how do I say this? So I have two answers. So there are a myriad of solutions given the complex problems, but allow me to just focus on two things. The first one I've already talked about earlier, which is what can we do as individuals, as citizens, to help fight the problem on waste. And I focus on waste, no? Okay, maybe I'll make it three answers. So the one on waste is really a matter of personal accountability and responsibility. So one of the challenges we've seen, and I'm sure maybe some of you would have already gone through this challenge, is you sort your waste, every type of waste goes in a bin, and then you see the truck come and everything goes into the same truck. So that I've also experienced that in one city. I don't want to name the city, and that is really, really frustrating. Um, but then at the same time, to be honest and to be fair, even if that is in that kind of situation, as long as they are bagged separately, they still create some level of ease with the waste sorters down the line. So your effort is not entirely for no value. Somebody still gets to benefit from that. And it's also crucial to remember that once some of the types of waste are contaminated, for example, cardboard, they become increasingly difficult to recycle when they get contaminated with organic waste. So it's also partly our responsibility to make sure that the ease of recycling and reusing them is easier because we've already done the part of protecting them. So that's number one. Number two, on decarbonization and sustainability in general, no, we need to be conscious about companies who are taking significant strides on decarbonization. So here we go into this whole argument of, our companies just greenwashing, who is really making an incredible effort, and who's the one that's just doing a lot of PR. I don't have any answers for you on that one. But what I can say is we need to be conscious about supporting companies who are doing something that's truly impactful on sustainability and decarbonization. Um, More often than not, we say we are for those types of values, so we share those values. But when it comes to spending and making our money do the talking, we always go back to price. And given our circumstances, maybe you cannot blame that, and you cannot make every decision be based on value. A lot of the decisions has to be based on price. But maybe what I would recommend is pick one product in your life where you can actually say, okay, this product I consume fairly regularly. Maybe the sustainable options are more expensive, but what if I make an effort to prioritize the companies and the products that are pushing the agenda on sustainability, and I try to stay away from the companies that I know have problems in this aspect. Just pick one product. You don't need to do it in every single aspect of your life, but try to learn from that and then see how it scales up to other. That's the second one. And then the third one is I need to remember what I was thinking of. Okay, the third one. The third one to academe. So let me speak to academe in general. So I've had various interactions with in particular UP Diliman, and we do a lot of work with the MSI, the Marine Science Institute. And in general, here's my comment. There's a lot of really good data and really good studies available from universities that paint the picture about where we are on waste, on pollution, on chemical contamination. The academe does a lot of good work. But somewhere in between, there's a very big cliff where information does not jump from study and research to policy. And I cite this example as an anecdote, but I was talking to graduate students in MSI, and they were doing a lot of research on plastic and contamination, and how it gets into the seafood and all that stuff. And then they were saying we're excited for our paper to be published, which is as a student really great. But my question is beyond that. So what is the end of the study? Is it for the paper to be published and then we're happy? Or is it to actually move beyond that and influence policy? So who are we talking to, and what avenues are available for us to share those findings, to shake the foundations and make people realize the problem is bigger than what we think it is, and to actually create something tangible out of the study? That part is still missing. So I encourage those who are into research to try to find ways to expose the outcome of your research more, and to hopefully get in touch with the people who can make decisions to turn that research into policy or into action. Because we have a lot of good research, but if it remains as research, I'm sorry, it's not really gonna create a difference. It makes us happy, we did our job, but it doesn't really help in the grand scheme of things. And truly, the most impactful work, you don't need to change the world. Just change the mind of one person and allow that person to do something about what you discovered, and that already makes a difference. Thank you, Edward.
Thank you, Engineer Mendoza. Shake the foundation. That's so proverbial. From Engineer Pimentel, maybe here our parting words for our audience. Sir, you have the floor.
So I feel like Engineer Samuel pretty much summed up a lot of the points that we can discuss regarding it. But I just want to double down on what he said. This is very important as well. Some students forget why we do research. Like, yeah, after we've done research, we've done our thesis, we try to publish it, we get some international body looking at our work. We have to always remember that our research has to have some impact. I just want to actually I was gonna say it, but Engineer Sam was pretty much summed up everything, most of the points. So I'm just gonna emphasize also on that our research needs to have some impact. Okay.
Thank you, sir. Our research needs to have impact outside the four classrooms, outside our journals. Thank you, sir. And again, let's give our virtual round of applause to our speakers, Engineer Pimentel and Engineer Mendoza. Thank you. At this point, we are now ready to award our certificate of appreciation to our speakers, to be flashed on the screen. and to be sent to our speakers. Let me read the citation. The University of the Philippines, Los Baños awards the Certificate of Appreciation to Engineer Gabriel Antonio I. Pimentel and to Engineer Samuel Manlosa Jr. in recognition for their valuable contribution and commitment as resource speakers in the second session of the Zoom webinar series on low carbon strategies and best practices entitled Decarbonizing Infrastructure, Nature-Based Design and Industrial Innovation, organized by the SEAT Interdisciplinary Low Carbon Research Center in collaboration with the UPLB Interdisciplinary Cycle Assessment Laboratory or ILCAL, given this 23rd day of October 2025. Signed by the chair of the UPLB Interdisciplinary Life Cycle Assessment Laboratory, our Associate Dean, Assistant Professor Bernadette T. Magadia, the chair of the SEAT Interdisciplinary Low Carbon Research Center, and the dean of the college, Professor Rex B. Demafilis. Again, a warm virtual round of applause to our speakers for joining us this morning. Thank you, sirs. Thank you, engineers. At this point, may we have a photo opportunity for including our speakers, including our dean, our associate dean, and the audience. If you can open your cameras, please do so for our photo opportunity per panel. And our technical team will be handling our photo opportunity. So the first panel, please keep your smiles. We don't know what panel we are in. Okay, next panel. We have 7 panels. Just keep your smiles. Okay, next panel. Okay, next panel. And the next. Then the next one. And then the next one, I think that's the last panel. Okay. Thank you everyone for opening your cameras. And to hear synthesis and closing remarks, may we hear from the chair of the UPLB Interdisciplinary Life Cycle Assessment Laboratory and Associate Dean of SEAT, Assistant Professor Bernadette T. Magadia. Let us
Thank
give
you
her
very-
our virtual round of applause.
Thank you very much, Sir Eggy.
Go ahead, ma'am.
Thank you. So first of all, before I forget, I would like to thank SEAT Dean's Office and the SEAT Interdisciplinary Low Carbon Research Center and the UPLB Interdisciplinary Life Cycle Assessment Laboratory for organizing this webinar series. And I'd like to particularly mention Ms. MJ Romualdo for heading the organizing committee for this webinar series. I would also like to express my appreciation for the positive reception of this webinar series because I can see from the audience that we have representatives from the academe, the government, the industry sector. So we feel like this is a platform where we can really share best practices. So going to that, our goal for this webinar series is really to have that platform wherein low carbon best practices and innovation strategies are shared so that our hope is for our nation to eventually have that or have lower carbon footprint in the future. Because again, as mentioned earlier by our speakers, our goal is for a more sustainable and decarbonized world. And that is our aim. Hopefully, we encourage collaboration, partnership, and dialogue through this webinar. I would also like to particularly thank yung ating mga industry partners who are really willing to share their practices, their experience on low carbon strategies and innovations. Particularly now, we have with us Engineer Gab Pimentel from the Base Bahay Foundation and Engineer Sam Manlosa from Holcim, who really put their time and effort to share their best practices with us and encourage us to do the same. So we thank you very much, our very esteemed speakers. I have noted some important information and inspiring words from our speakers here. First is from Base Bahay. So, based from the data that was given to us, 38% comes from the construction industry. And indeed, from that, we know that there is a lot of things that we need to do to decarbonize that industry. And we appreciate very much the presentation of Engineer Gab, because we see the potential of our own resource, particularly bamboo, as an alternative nature-based material that is more sustainable than the conventional one. Additionally, for the presentation of Engineer Sam Manlosa, I've gained a lot of insights and realizations from his presentation, particularly on looking at the bigger picture. Sometimes us as engineers, we are so focused on the production side, being it the culprit of what is happening right now, especially on the environmental impacts. But we realized from the presentation that the issue on the end of life of our whatever we are consuming, particularly on landfill, and also the way we consume things, is really a bigger problem than what we can think of in terms of the production. So the concept of circular economy, decarbonization, and how to make our waste more valuable, and that's what they did with the GeoCycle, is really very inspiring. So kudos to Holcim for those kinds of initiatives. In closing, siguro, we were given a challenge, especially the academe from their closing or parting words. The challenge for the academe to really have our research be more impactful, and at the same time be translated into policy, or even be recognized by the industry. And I guess that's what we've been doing, particularly in SEAT, trying to reach out to these government institutions as well as the industry in particular. That's why we also have this kind of platform to really hear from the industry and actually start the collaboration. And that is in our SEAT Ascend framework. So that's a challenge that we are willing to accept, but hopefully, and I guess the main message here, and as indicated by Engineer Sam Manlosa earlier, there has to be a concerted effort, not only from the academe, the industry, but to all the stakeholders that could really push forward this decarbonization initiative of the government and the whole nation. And it is also highlighted again, there should be a proper interplay of policy and innovation so that we will have, particularly in this topic, better and more sustainable construction industry. So I guess I'll end with that, and I'd like to thank again everyone for joining us in this webinar series. Thank you.
Thank you, Ma'am Bea, for our synthesis and closing remarks. So that summarizes what we've learned in our webinar. We are requesting one more photo op, including specifically Ma'am Bea, Sir Rex, and our speaker, Engineer Mendoza. I think Engineer Pimentel has already left the meeting. Just one more screenshot for including our Dean and Associate Dean and our speaker. So sila lang po. Okay? I think we're now ready for the photo op. Ayan, nandiyan pala si Engineer Pimentel. 3, 2, 1. Okay. Thank you very much po.
Salamat.
And
Salamat.
thank you. Thank you very much po. And please do not forget to sign up register your attendance, and the evaluation form is now flashed on the screen for your certificate of attendance. And again, this has been the second session of our webinar series on low carbon strategies and best practices. In particular, our theme for this webinar is decarbonization infrastructure, nature-based design and industrial innovation, presented to you by the College of Engineering and Agro-Industrial Technology in collaboration with the SEAT Interdisciplinary Low Carbon Research Center and the UPLB Interdisciplinary Life Cycle Assessment Laboratory, with our speakers from Base Bahay Foundation and Holcim Philippines Incorporated. Again, thank you very much. Please do not forget to sign up, answer the evaluation form, and see you in our next webinar series.
Thank
Thank you and good afternoon.